All right, we're going to look at number 16, and I think we'll also do number 19 in this one. So let's take a look at this. We have this negative 64. Now, if this were a square root, we would know we have an I. But if it's an odd root here, we know that we have can have a cubed root of a negative number. It will just be negative. So we know our answer will be negative. Now let's think of 64. 64 is 8 times 8, and 8 is 2 times 2 times 2. So we actually have 64 is 2 to the 1, 2, 3, 4, 5, 6, 2 to the 6th. And so we can think of the cubed root of 2 to the 6th, a to the 6th, b to the 8th, and a negative. Now negative is not within here, so the negative's outside of the 2 to the 6th, if you want to make sure you think of it that way. So cubed root of a negative is automatically negative, because a negative times a negative times a negative is negative. So then we have this 2 to the 6th. Well, it's this first one we're going to do perfect cube. So 2 to the 6th can be split up into 2 cubed times another 2 cubed. And then a to the 6th is a cubed times a cubed. And then b to the 8th, this is where we run into something different, is b to the 8th we can write that's b cubed times b cubed. That's only 6 b's though, and we have 2 left over, which will not be a perfect cube. And so our answer, or working towards our answer, is we got the cubed root of 2 cubed is 2. The cubed root of 2 cubed is 2. The cubed root of a cubed is a. The cubed root of a cubed is a. Cubed root of b cubed is b, and the cubed root of b cubed is b. That was a lot to say. And then this one cannot be simplified, so we keep that as the cubed root of b squared. And finally, we have our answer of negative. Oh, I did something wrong here. We're taking the cubed root of this, so I should not have put a cubed root here. So we need to get rid of that. So that's not a cubed root. I apologize for that. Maybe some of you caught that. So this is negative 4 a squared b squared times the cubed root of b squared. Let's do one more similar to that. We have the 4th root of 64. We actually just worked with 64, and we saw that was 2 to the 6th. So we have the 4th root of 2 to the 6th, x to the 7th, y to the 4th, and z to the 7th. This is where we'll take things that are perfect cubes, to the fourth roots, and things that are not. So this 2 to the 6th can be split into 2 to the 4th and 2 squared, because the 4 plus 2 is 6. X to the 7th, we'd have an x to the 4th in there, but then we have an x cubed left over, which is not a perfect 4th root. We have y to the 4th, so that's good. We have no y's left over to put on the other side. And z to the 7th, we can write z to the 4th, and then z cubed. The things on the left are perfect cubes, and it's actually just 2xyz. And in the radical on the right, we have 4, because 2 squared is 4, x cubed, z cubed. And that's the answer to that one. And that is how you do simplifying radicals.